Right, so we will continue. I was talking about the third kind of test, which is testing for two means, but the dependent samples. So what do I mean by dependent samples? Let's say you have a set of children, right? And let's say this is children from poorer families who don't get enough nutrition. Okay, so what you do is you measure the average weight. You measure the average weight, and you find that it's W1. Okay, let's say there are 100 such children, and then you give them a supplement, a food supplement, and you make them eat it for 6 months. This could be spirulina, or it could be chyawanprash, or it could be some protein supplement like Pediasure or something, some supplement. You give it to them for 6 months, and then you measure the weight again, average weight, and that's now it's W2. So this is a different sample. The same set of children you are measuring before and after. So it's called a dependent sample. And the way you formulate the problem is for child 1, weight 2 minus weight 1. So child 1, and like for child 2, weight 2 minus weight 1, and so on and so forth. So that is the way you calculate the the mean difference, and then you apply the test. Right? You apply the test like any other. You take the appropriate, go in spaces or Excel, click on the appropriate test for difference between two means, dependent sample. It will tell you, it will give you the user interface. You would say, what is my first sample size? What is the mean? What is the variance? What is the second sample size? What is the mean? What is the variance? Press enter, run the data. It will give you the output, and you can calculate P is equal to 0.03 or 0.05 or 0.07, and they can conclude whether the difference between the mean before supplement and after the supplement is significant or not. Now, if it is significant, then we conclude that the weight of the children has changed in the 6 months period. Can we conclude that it has changed because of the supplement? That is not the statistician's job. That conclusion you have to see whether has otherwise everything else in the child's living conditions remained the same. Are they eating the same kind of regular food that they were earlier? Is it the same level of exercise? Is it the same level of overall nutrition and health and so on and so forth? If the only difference is because of the supplement, then you can conclude that the difference is significant, and the difference is probably because of the nutritional supplement that we have given. Right? So as I said, statistics finishes at telling you whether the difference between the two means that we measure is significant or not. Right? Okay, so far, so we have covered 3 tests. Test of difference between two proportions, test of difference between two means when they're independent samples, that is different samples. Test of difference between two means when they're dependent samples. The same set of respondents have a pre and a post measure. I am not teaching you the formulae. You don't need to know the formulae. Unless you're going to spend a career in statistics, you don't need to know the formulae. As a market researcher, it is nice to know the formula, but it's not essential to know the formula. I'm teaching you assuming that you're looking at market research as your option here. Right? Let's go forward. So now we come to the 4th kind of test. Test between multiple means. So let's say we have a brand, okay, and we're running different consumer offers for the brand. So in City 1, we run an offer of a free pen. In City 2, we run an offer of a free geometry box. And in City 3, we run the offer of a free Scotch-Brite. Free Scotch-Brite along with the brand and free geometry box along with the brand, etc., etc. In city 1, let's say the average sales in the shop is 150 units per month. Let's say in city 2, the average sale is 175 units. In city 3, the average sale is 185 units. Now we want to compare the 3 means. The earlier formula that I talked about only about 2 means. So that's not applicable here because here we have 3. So what do? We run a test called ANOVA. Stands for analysis of variance. Right? So remember, test 4, ANOVA applies when you're trying to test the difference between multiple sets of means. Test 1 is a test when you're testing between 2 proportions. Test 2 is a test when you're testing between 2 means, independent samples. Test 3 is a test when you're testing between 2 means, dependent samples. Test 4 is when you're testing between multiple means. And here, this is called an ANOVA test. Right? Remember this. The rest of it is the same. You run the test, you get the result. From the result, you read whether it is significant, not significant, etc., 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 etc. Now, finally, the final test that I'm going to talk about, because these are the 5 most common tests that we use in market research. There are many other tests. There are tests of randomness, there is Wilkinson's, etc., etc. I'm not even going to talk about that. I'm just talking about 5 significance tests. And the last one that we're coming to is chi-square. Now, the first 4 tests that we have talked about, they are called parametric tests. Because you're testing for a parameter. The parameter could be the proportion, or the parameter could be the mean. Because you're testing for that, it's called a parametric test. The chi-square is a non-parametric test. Okay? The chi-square is testing between distributions. So percentage data. It works only with nominal data. Please remember this. This is important. The chi-square is an appropriate test to test between distributions when we are talking about nominal data. Nominal data, to refresh your memory, boy, girl, Bombay, Delhi, Calcutta, Madras. This is nominal data, right? So let's say we have a hypothetical situation when we have a client, let's say a finance company. It has got customers in 4 cities. It got customers in Bombay, Delhi, Calcutta, and Madras. I'm sorry, let me update my knowledge. Mumbai, Delhi, Kolkata, Chennai. Right? It's got customers in the 4 cities. In Mumbai, it's got 4,000 customers. In Delhi, it's got 3,500 customers. In Kolkata, it has got 1,000 customers. In Chennai, it's got 800 customers. Therefore, the total is 4,000, 7,500, 8,500, 9,300 customers. Okay? So now we do a sample. We do a random sample of these people. Okay? And we take a random sample of about 1,000 people. Or let's just say we take 930 people to make our job a little easier. Okay? So, and in this random sample, we find that we have 411 Bombay customers. We have 322 Delhi customers. We have 118 Kolkata customers. So 118 plus 322 is 440, 811. And we have 119 Chennai customers. I hope my maths is correct. I'll just double check this. 119 plus 411, 400, 500, 530, 830, 852. What am I doing here? I'm doing something wrong, right? 322 plus 118 is 440 plus 440, 851. So this can't be 119, sorry. This can only be 79 customers. So 411 plus 79 is 490 plus 100 is 590, 608. Yeah, correct. So this is the actual number of customers that we have got in our sample, 930 customers. Now the question is, the distribution that we have got, it is sort of similar to this that we can all see. 4,000, exact number would be 400, it's 411. So it's sort of similar, it's not that different. But is it different? Is it statistically the same or is it statistically different? In this situation, we run a chi-square test. Now, in chi-square test, we first run what is known as an expected. We understand expected distribution. So, if in 9,300 population there are 4,000 customers, then in 930 there are 400. There should be 400 customers. There should be 350. There should be 100. And there should be 80. And that's 930 for you. Right? 450, 750, 850, 930. This would be the expected distribution if our sample distribution is exactly matching the population. But our observed distribution is 411, 322, 118, and 79. Right? So this is now, we compare the observed versus the expected. There's a formula for that. You calculate something called the chi-square, and then you see whether the calculated figure is statistically significant or not statistically significant. That again, maths, formula, I'm not touching it. But the key to remember in chi-square is there is an observed distribution which has come from the sample. There is an expected distribution that you have to calculate, and you would compare these two. Now, the kind of example that I'm talking about here will not come too often in your textbooks, which is why I'm saying that the skill lies in deciding which test to use and to formulate the skill carefully and to formulate the test carefully. Right? So I am ending this chapter here. I'll just repeat this. Significance testing is completely about calculating the probability that the difference we observed can occur only because of chance. It calculates the probability. If the probability that can occur only because of chance is high, then it means that the difference we have found is not significant. If the probability that can occur because of chance is low, then it means that the difference we have observed is a real difference and not because of sampling error. In a one line, if you can understand this, you have understood significance testing. The rest of it, the other important thing to understand is which test to use in which situation and to formulate the test appropriately. If these three concepts, what is significance testing conceptually, which test to use when, formulation of the test carefully. If you can understand these three things, the rest of it, a software can take care of for you. You don't really need to do anything, right? The rest of it is mechanical, which if a software can do it, any back office can do it for you. But the first three things is where the real skill and where the real knowledge lies, right? I hope this bit is clear. So I'll stop this chapter here now. Thank you.